Now for number 3, could you go ahead and write down all 3 transformations? We got 3 numbers right here that will correspond to 3 separate transformations. Can you write them down? What are the 3 transformations? Up 1, yes. Now I would put the up 1 right at the end. Left 2, wonderful. And what about the 5? It's a vertical stretch by 5, okay, by a factor of 5. Now, how will these transformations be impactful? Now, I'm going to do something, and you can hold off the drawing part as of now. I am going to show you the original dots that you're supposed to draw, but they will change, okay? So don't draw it on the graph just yet. Now, it's going to have a vertical stretch. That means it's going to influence the y value. So this point right here, it's 1, 1, right? Because of the vertical stretch, the y value is going to change from 1 and multiply by 5. Okay? And on the left, this point is -1, -1. Again, do not draw anything yet. I'm not done. So just, look. So this point, again, will get stretched. So from -1, -1 to -1, -5. Okay, so that's the vertical stretch. And then we will shift to the left by 2 units. That would impact both. So we go to the left 2 units. And then we'll move up 1 unit. Okay, so these are the points. And now I want more evidence to make myself comfortable with these 2 dots. So what I'm going to do is this. I'm going to think about x being -1 because I want to verify the validity of this point. So I'm thinking about if x is equal to -1, I put it here in the function. Do I get the same point? Well, think about this. -1 plus 2 is -1 plus 2 is 1. 5 divided by 1 is 5. 5 plus 1 is 6. Okay, we're good. Okay, we're good. And for this particular point, x is equal to -3, right? So think about x being -3. What's -3 plus 2? -1. 5 divided by -1 is -5. -5 plus 1 is -4. Do we have -4? Yes, we do for the y value. So now we can confirm that these 2 dots are absolutely spot on. And then we can go ahead and do our vertical asymptotes. And when we look at the denominator, it is x plus 2. That means our restriction must be -2 because we do not want the denominator to become 0. And that also agrees with our shifting to the left for 2 units because originally our vertical asymptote is at the y-axis, and now we shift it to the left for 2 units. Yeah, we can do the graph now. And then the horizontal asymptote is being shifted up by 1 unit. If you want some further explanation why the horizontal asymptote is y equals to 1, here's a little explanation. Again, what's the meaning of horizontal asymptote? When x becomes what? Infinity, right? So think about this. What is infinity plus 2? It's 2 infinity, right? What is 5 over infinity? That's practically 0. Okay, and then 0 plus 1 is 1. That's why y equals to 1. Okay. All right. Yes.
I understand how you got the first point, the one on top, but how did you get the second?
This point right here?
Yeah. No, the other one.
This one?
Yeah.
Well, first it was a vertical stretch, right?
Yeah.
So -1, comma -5.
Yeah.
And then we moved left 2 units. So we went left 2 units, so -3, comma -5. And then we shift up 1 unit, so that's why it's -3, comma -4. Okay, so that's why the order matters. The center of rotational symmetry will be at -2, comma 1. That's where the two asymptotes would intersect. For the intercepts, we know what is 0 for x-intercept. It's the y value becoming 0. So if y becomes 0, then we'll go ahead and find out what it is. Okay. Now, x plus 2, you can multiply x plus 2 on both sides, and then divide by -1 on both sides. So that becomes x plus 2 on the left, and then -5 on the right. Again, you can think about multiplying x plus 2 on both sides, and then divide by -1 on both sides. So so you can get the you can eliminate the fractions here. So x plus 2 equals to 5. So that means x equals to -7. So your x-intercept is -7, comma 0. Okay. All right. So that's the x-intercept. The y-intercept is when the x equal to 0. So that's easy, right? So for the y-intercept, it's when the x equal to 0. So 5 over 0 plus 2 is just 5 over 2 plus 1. So 5 over 2 plus 1. So common denominator would make this 1 into 2 over 2, right? That's how you do common denominator. So 5 over 2 plus 2 over 2, that becomes 7 over 2, which is like 3.5. So that would be at my y-intercept. All right, so that's the graph. And so again, when you draw the asymptotes, the graph should lean closer to the asymptote as it goes towards it. And then the domain, so the x values will be everything but -2. So the way we would describe the interval is from the smallest value, which is -infinity, to -2, parentheses. And then from -2 to infinity. Okay, because the x values are all good except -2. The y values are all good except 1. So these information the information here should be very visual. You can extract it directly from the graph. Okay, so make sure you get the initial 2 dots plotted accurately. Not here. This dot and this dot right here. Make sure you know how to do this. Okay, you can watch the video if you need to go over this again. But again, you want to make sure you take care of the stretch first, then the shift. Okay.